Okay, great. So I think post-lunch first session, that also in the second half of the last event day. I think my responsibility is to keep you awake. So let's try that. Uh, so I'll just start with some interaction. So how many, or I'll say, anyone who has not used ChatGPT till now, or don't like to use ChatGPT, or don't want to use ChatGPT? Okay, but something you want to use. Okay, that's great. That's what I expected. I thought I should not get a surprise. Okay, then in that case, I think most of you or everybody must have heard about DeepSeek also. Okay, so the recent one. Uh, and anybody working on agentic AI, trying to do something on agentic AI, trying to solve something? Great. I think then we are moving forward and would like to speak to you guys to understand what you are doing. Uh, if, or let me just put one more question. How many of you think that AI is going to take our jobs? Okay. There are few. Okay. I think most of the people don't think that it is going to take our job. And let me reinforce that. I think I also believe the same. Uh, I have some thoughts over that. So the first one is, I think our previous generation thought that computer will take our job. And I think here we are because of that computer. So it laid a path for future generation, for future innovation. And I think it's the same thing what is going to happen with AI, Gen AI, agentic AI, or I would say any form of AI. So that is first reason. I think it is not going to take our job. It is going to maybe create a lot more I'll say, in India and across the world. And I think we are fortunate enough to be in this era. We are going to see lots of transformation, and we are going to see lots of new ideas, disruption coming our way. So the second thing, or I would say second reason why I think that it is not going to take our job is, so I work with lots of CXOs. Okay, I have worked with lots of CXOs. And the CXOs are of our generation, or let's say previous generation. And what I have observed that uh, they are slow. I'll say we are slow in adopting this technology to the actual or real use case. And why we are slow is the reason why we are right now here. We are going to talk about it. Why the slowness is because of the way things has been done in past, and what should be done to ensure that it speeds up. But that gives us a good amount of time to say that, yeah, we are not going to lose our job to AI. The third thing, which is not kind of reinforcement, but it is something which we should be watchful, as you all said, like, okay, you already know about DeepSeek. You are already using ChatGPT. Some of you are using agentic AI to implement or solve some problems. So I think we are watchful to that. So the part which I want to say is we should be watchful to the tech entrepreneurs, the disruptors, the innovators, because they are going to continue disrupting what we are doing right now. And believe me, I think the things, with my past experience, what I have seen, the things which used to take a decade are getting done in a year, or maybe even lesser, and that is going to continue. So just be watchful about what disruptions are coming and adopt that. Use that. I'll not say adopt it, start using these technologies, and that is going to help. Now, let's come to our topic. Means I just wanted to set the context correct, like why we are having this conversation. And again, this is moving forward to similar thing in the ecosystem. So we want to talk about data first, okay? Before coming to data architectures, let's talk about data. So data is growing, and I think by stats in 2015, the total data size in the world was 15 zettabyte, and by 2024 end, it is 147 zettabytes. So 1 zettabyte is something 10 to the power 21 bytes. So it's huge. And 15 zettabytes we created in almost 30 years, okay? And it became tenfold within next 9 years. So imagine how fast it is growing. And the reason for the growth is the connected system, the internet, the unstructured data which are getting stored. So there are many reasons for this growth. And it will continue to grow because the way innovation is happening, we are using, let's say, the Gen AIs or agentic AIs, they are further going to increase the size of data. And if we are not prepared to handle that data, I think we are, as an organization, I would say, not as an individual, as an organization, we are going to lose to our competition, okay? So data is going to become a primary reason for success or failure of any organizations. Though people say AI or Gen AI, but the basis is data. If you don't have right set of data, I don't think you'll be able to leverage the technology. Data is backbone of AI or any form of AI, whether it is generative AI, agentic AI. Without data, we are not going to have any of these innovations happening. Now, these are basis. Now, the topic which we want to cover is the traditional data architecture versus the new age data architecture. So, the traditional data architecture, we have lots of struggles which we are going to cover, or I'll say we'll cover few. Generative AI, because it is moving fast, and if we want to adopt, we need to have the modern data architecture. Poor data architectures leads to lots of issues with Gen AI and AI. I think we have lots of new constraints coming in. Okay, earlier with rule-based system, I think we were bothered about security and some more constraints towards that, but primarily it was security. But with AI and Gen AI, the constraints are evolving. So we have to ensure that our data is the architecture of our data is good enough to ensure there are no compliance issue, there is no biasness, there are no security risks. So that's the reason why I need to move to modern data architecture. Okay, before again going to modern, or I'll say the drawbacks of traditional data architecture, let's talk about what is a data forward organization. Means which organization can be considered a data forward organization. So I started my career with a application developer or a SaaS developer, software developer. And I think for longest period of my career, in my mind, what used to run was how to solve a problem. And the first thing which used to come in my mind is N-tier architecture or 3-tier architecture. Okay, we'll store the information here, we'll do the business logic in in the middle tier, and then we represent it on our UI. So I think why I said like, okay, the adoption is slow, because as many organizations or most of the organizations are still thinking the solutions in the same way. We are not making systems data-centric. Okay. We are still thinking like, okay, let's store the information and let's have our business logic in our middle tier, and then let's consume that from UI and show, or let's say do the transaction. Now, if we have to become a data forward organization, we have to ensure that the data starts powering everything. Okay, you don't focus on the middle tier or the top tier, you start focusing on data. Okay. Again, I'll share my experience when I started my career. Uh, I used to work for a manufacturing execution system, which was huge, a very complex application. And in my experience, or when I started, I became confident by seeing what is the data model, what is the database, what kind of data is being stored. Because as soon as you see that, you start relating it with real world, and you are able to understand what this application does. And it has helped me a lot for long period of time. The first thing what I see in an application is like, okay, what is the data model, or how the data is stored, or what kind of data is there in this system. That gives me the kind of blueprint of what this application is about. Then came this ORM days, or entity framework, or serializer, whatever we call. People started moving away from this data and started focusing on middle tier. So I think we have to go back to the data. We have to see all our business operations, how they are data driven. Are they leveraging the data what they have? I think most of you must have seen this viral video of Satya Nadella, which says like, okay, the SaaS is no more, or SaaS is going to die. Though I think that is too far, but just imagine your organization does not build everything by yourself. Okay? You use lots of SaaS applications as an organization, or many of you are building those SaaS applications and giving it to your client. So how we are going to make a data forward organization? If I have some data in SaaS, that is in Salesforce, I have some data in my ERP, okay? I have some data in my custom application. My mobile app is running with data somewhere else. So how we are going to become data forward organization? We are not able to consolidate all these informations. We are not able to build the data architecture which is helpful to take decision based on all this information, okay? Because whichever department you serve or your applications serve are interrelated. It's not like finance can run independently, or operations can run independently, or sales and marketing can run independently. So all of these has to feed each other for making the business successful. So we have to see how we are empowering all these applications. Means now, if you see, there are many organizations who are setting up their data lake and serving the information through data lake. I think that is one step forward. That is kind of solving the issues. But yeah, not everybody is doing it. Okay. We'll also talk about AI, what people think AI is. So this again comes from the thought process of three-tier architecture. We just see like, okay, yeah, we will have data. Then there is an AI layer, which is like our business logic layer. And then the value, which is the inference, what we generate from AI. Thinking like, okay, yeah, this is what AI is. What actually AI is, okay? So AI, if you see in this whole system, there is first part data, and there are lots of things which happens towards data. If you see the middle part, again, it consists of the data engineering layer, which is much bigger than modeling or any other thing, let's say tuning, or let's say building model, or using some Gen AI tool, or anything. Then comes the value. Okay? And the constraint which I was talking about, earlier the constraints was primarily security. Okay? We were, and with, I think, recent incidents post-2020, I think it has still very, what do you say, I'll say scary, or it's important to take care of that. But it is going to become more, or it is going to become scarier if we don't take care of this constraint, or we don't handle this constraint very well. So security is very important thing. Let's take, if you know authorization, okay? Just imagine how you are going to deal with authorization with so much data or different systems. Just a simple example I want to give. Along with that, the additional constraints are bias, transparency, legal challenges, So how we used to develop our application three-tier architecture. We used to write rules. And when we used to write rules, we were confident that whatever we are writing is, is good. It is with our best conscious, like, okay, this is going to do right thing. Now, with AI, again, it is generating rules in form of model, but those are based on data. So, but how you are going to validate or how you are going to check whether this rule which came out or the output which you are getting from this model is correct or not. Now, where there are classic examples, so one thing which I would say, let's say you generated a model on top of your data, and it gives something incorrect, which has some serious impact. Who is responsible for it? Let's say you are using a third-party model. You are using a model, can you say that the model is responsible? Don't know. The data may be responsible. So who is responsible, the model provider or the data provider? So there are conflicts like this. And these are serious problems which needs to be solved. And it can be solved only through modern data architecture. And the term which I would say is explainable AI, okay? Means if we have explainable AI, then only we'll be able to solve these issues. Because AI is not magic, okay? It's not like, okay, we are asking something, it is giving the answer to us and it is doing some magic. It has to be coming from somewhere, okay? The things which I have tried, if I find there is a problem or the result is not correct, I should be able to drill down to find out why this result is incorrect. So what are the challenges with traditional data architectures? Okay, so batch processing. Okay, batch processing has its limitations. The data freshness is one. Data recovery in case of failure is another. So like that, there are multiple. So today I was dropping my kid for school. So today, most of the school shows the real-time tracking of bus. The bus is coming. Just imagine if we don't have, if we are processing that through a batch, are we going to see those real time? No, we are not. So the need right now means the consumer behavior or the usage pattern is such that everybody needs the information immediately. So batch processing is not going to solve our problem. The real-time data need, the example which I gave, I think is relevant to that also. Handling massive unstructured data sets, okay? Before the smartphone came, or let's say earlier, why the data size was not growing that fast, or the data which we had earlier was mostly structured data. And we wanted to be it structured. Means anything coming to us, we thought, okay, let's make it structured. Anything unstructured, we wanted to transform it to structured format. That's how we build our system. But with the size of data sets, or the growth of data sets, we can't do that anymore. We have to deal with unstructured data. So we have the traditional data architectures don't have that capability. Lack of AI-specific data stores, real-time model tuning or inference is required, and that is solved by data stores. That is also not there. Data in silos and governance gaps. So we'll cover governance gaps in later part of this slide. But if we see data in silos, I gave the example like, okay, you have different application and everybody is dealing with their data. They don't want to collaborate and then see what the inference can be drawn with that. So we call it AI native data architecture, we call it future-proof data architecture, we call it modern data architecture. The context is same. What do we need from that? Okay, the data architecture should be scalable with low latency and should have flexibility. Some of the components will touch base. I'm not going to talk about everything of modern data architecture. Let's touch base on few things. Real-time data streaming, that is needed. Distributed feature stores, vector databases, and data governance. So let's talk about real-time streaming. Okay, what do we need in real-time streaming? What is the benefit of real-time streaming? So we need lower latency, we need continuous learning, we need real-time interaction, and scalability to dynamic environments. Uh, the example, one which I gave, or let's say we have Google Maps, okay? If you get a traffic updates on your route which is 1 hour old, I don't think you'll like it or Google will survive. So real-time streaming is very important from that aspect. There are lots of tools, Confluent, Kafka, Flink, Delta Stream, even the biggest cloud providers for AWS, we have Kinesis, Event Hub in Azure, PubSub in GCP. So this is what you can use for real-time data streaming. And you should start thinking, like, okay, is real-time data streaming required for your application? And the way how you are doing today, is it correct? So explore these solutions. That is going to give you idea how powerful these solutions are and how you can leverage this power to make your application next level. Second is distributed feature stores. Will not talk too much, I think, in constraint of time. But the idea is the machine learning models, whether you are generating the inference or you are tuning again. For that, you need embedded data systems, data sets. So that is not there in traditional data architectures. So I would say explore this. Will not touch base. I just wanted to cover some more things which are much more interesting. Vector database. Vector database, if we know or if you are already exploring AI, so there are multiple layers with after Gen AI came in. So when we say like, okay, we want to solve problem using Gen AI, the first layer is prompt engineering. Okay, that solves most of our problem, and it is easy to adopt. It does not need very high skill. The things which can't be solved by prompt engineering, that's where RAG comes into picture. Okay, so if we say like, okay, 60–70% of the problems are or can be solved by prompt engineering, the next set of things we have to use RAG. And the basis of RAG is vector database. Without vector database, that is not possible. So what it brings in efficiency in similarity search. It handles, or I will say it creates multi-dimensional data from your unstructured data. If you just put a file or image, it is going to create a multi-dimensional data within it. So there are many solutions or many vector databases. I have used Pinecone by myself, and it is quite interesting. You can explore. And once you start exploring vector database, you'll see the power of it. And again, you have to see how you can use it in your setup, your scope, and how to leverage that power, how to leverage the power of Gen AI beyond prompt engineering. Then data management and governance. So I have created 3 persona, and then 4th one is application. Again, this is inspired from Databricks. So if you see, we have who are the consumer of data? The data analyst, the data engineers, ML engineers, and the applications which we are talking about. The applications are going to consume this. Now with AI coming into picture, what is their questions or what is their problems? How to discover data sets, how to discover the notebooks, how to identify the dashboards, okay? And another question is, can I trust, as the example which I gave, if there is a model which was giving certain result and started giving some other result, means how you are going to trust that? Then data governance team, I think they have much bigger problem in terms of ensuring these assets are secure, okay? They are able to put right access. They understand who are using this. The data, all the information is compliant to regulatory bodies. So data governance becomes very important. Now, how we can solve these problems? Okay. So ensuring data quality, ensuring compliance and security are at place, ensuring it is ready for AI lifecycle management, okay? And how we can ensure that? By, uh, by solving the problem of, or by tracking data lineage, by data observability, by ensuring access control, by data versioning. Uh, I'll touch base on data versioning, or I'll say, let's say, if we have to have an explainable AI, we have to ensure that these things are taken care. How we can solve the problem of explainable AI, or if let's say there is a behavior which is not, you are not able to understand what is happening in your system. First is data versioning. As we talked about, whether the problem is in model or in data, that can be solved if you have versions of your data, okay? It can't be like, okay, you are dealing with a transactional database where you are overwriting everything and you are not able to track the version of your data, okay? So to ensure that you are able to you are able to implement a explainable AI, the data version is very important. Data lineage, okay? The next level, if you have to drill further, like, okay, what is leading to these results, whatever results I am getting, you have to ensure you have data lineage implemented in your system, okay? And access control, I think in general, if I go back previous, if we see all this persona, can we give access to everything to everyone? No, we can't, okay? So the access control becomes very important and we have to solve. And I think these are solved problems. There are good applications who are already solving. As I said, I took this from Databricks. So they have this Unity catalog, and there are other providers also who has already solved this, and they have solved it beautifully. So start exploring those, that how we are going to understand, means what is data lineage, how we are going to solve that problem in our data, how we are going to ensure that data versioning is maintained. Okay, so the best practices for future proofing, or I'll say modern data architecture: standardize your pipelines, enable AI observability or data observability, and invest in modern AI native or modern data architectures. Okay. So that's it from my side. I think we have 2 minutes. Any question, I would like to answer that, or we can always talk that after this session also. Yes, sir.
What's been your experience with knowledge graphs or neural DBs?
Hmm.
What's been your experience around that?
I don't have too much experience on that side. I think I have explored more towards how data can be managed best. Okay, the application I have left to somebody else. Or we can talk a little bit detail how what we have done and how it has solved, or I can talk to someone and get you the answer.
Any more questions?
Yes.
Most of the organizations that you see, we have the SQL Server databases, we have the Oracle databases, and obviously to have a proof of concept, you're going with the pine cone and all. So where do you see the world where you don't transition all the way to that side? You still have the traditional applications. You always, I mean, as of now, if you see, there are some data is always in the SQL Server, some data in the pine cone. As you see, it's all in Salesforce. As a data-driven, I mean, as you see, let's say there is a current startup, which like I would rather say there is a 2-year upcoming startup. There is no clue about what SQL Server is. Okay.
Yes.
For that startup, where will they start?
See, again, it is very specific to what problem we want to solve. I'll not say just start using all these heavy technologies without even seeing that scale is coming or the need is coming. Okay. So first thing is that. Second, whether it is Oracle or SQL Server, I think they are also trying to compete with these modern data architectures, or at least their providers are creating new options for adopting the vector database or the distributed data store. So they are also trying to provide. The reason is they know that there is a problem which has been solved with a traditional database, but that is not something what it was meant for. So let's not try to abuse it. Let's continue using it for that purpose. If I say the transactional system, okay, there is nothing better than these relational database for transactional, or there are some new NoSQL DB also, but that is primarily for transactional. But once your data start growing, or let's say you have a business or you have a startup which is relying on, let's say you create a Google map, means or replica of Google map. Now that can't be built on a traditional database. We can't think like, okay, let's use Oracle or MongoDB and then we'll be able to solve this problem. So what I wanted to showcase was like there are lots of options available. If we just explore, we'll be able to solve our problems in much better way, much scalable way. Yes.
Hi, you mentioned lineage sometime.
Sorry?
You mentioned data lineage.
Yes.
Any tool which can give me end-to-end lineage across all my sources and targets using AI? I don't need to go in and drag and drop. The AI just shows it to me where it came from, all the transformations without, at the click of a, do you know of any such tool?
There are many. As I named Databricks. Databricks provide the data lineage.
But across all different kinds of sources, Databricks gives it internally.
Yes, yes. It's not like Databricks is not something where it gives its own source, like Delta Lake or something. It works on top of Redshift also. It works on top of any other data lake, means it plugs with all those things.
But all the streaming stuff used for all the different types, even vector database, even for end-to-end, different types.
Yes, yes. Okay. And there are few more, nothing coming top of my mind, but I have seen that there are many options. The thing is you can't implement everything. You have to choose one and then move forward.
All right, I'm so sorry, we're out of time. Kumar, you will be available outside the hall,
Yes,
so if you
yes.
can just connect with him outside. So thank you
Thank
so
you.
much for that session.
Thank you.